Hello everyone, good morning. Okay, so in the today's session, we'll be talking about Git, right? So if you remember last session, we discussed about DevOps basics, right? And again, today we will continue with basic revision, what DevOps it is. And we have installed Git on our local machine. And even I have shown you how to create GitHub repository, right? Today it is time to understand the concept, like whole concept of the Git and how the tester can, simple push their code from the local machine to the remote site. Every architecture and all, whatever necessary file steps has to be followed right by the tester. Every point I'm going to discuss today. But before coming to that, we need to understand what does mean by version control system, right? So guys, this is our today's topic. Let's continue. So very first, let me discuss with a basic example. Just assume that we discussed in the last class what is DevOps, right? So DevOps is all about one kind of process where one team is able to manage complete development and operational team, okay, their certain tasks and their operations. That is called simple DevOps. So it is a culture, it is a process where one team is able to manage both the tasks, development plus operational team tasks. So DevOps is all about continuous integration, continuous delivery, continuous deployment, continuous monitoring, everything, right? So starting from the build, testing, integration, even you can say continuous delivery, deployment, and the monitoring. That whole process we can refer in the form of DevOps, correct? So normally what happen? We simple work in a team, right? Now just assume we have many developers available in that team, and suppose every developer developing certain module, correct? And what is the process? They are developing that module on their local machine. Now, why we need version control? You need to understand this part first. Now, you can just consider a group of tester, group of developer, doesn't matter. Where exactly they are going to write their logic? On their local machine, correct? Now, tomorrow, suppose all three developers working on a same module, they have some payment gateway to be validate. In that case, every developer, whatever changes they will complete on that particular file, right? Suppose if there is a possibility, they might have some drive mechanism. Okay. If they have a drive, and on that drive, if they maintain one file, and everybody wanted to make the changes inside this main file. Okay, suppose this is our file, and everybody wanted to make the changes here. Now, what is the problem in this scenario? Fine, the file can be downloaded on their local machine. Then developer A will make some changes and developer A will update the file. Fine. Same file will be downloaded by developer B, and developer B also make the changes and he can upload the file again into the drive. Now, in this process, developer C will not able to track because every changes occur and happen in the same file. So developer C is not able to understand, okay, who have made these changes, when the changes get made, right? And who is responsible for this change. Developer C can do what? Okay, again, C also download the file, make the changes into file and C will upload. But for every single task, you guys are maintaining only one file. And tomorrow, if your customer, right? Customer is the king in IT. So tomorrow, if customer comes and customer asks you, okay, that's it, fine, you have completed the module. Now please give me history. How many changes so far you did? What the changes you did? Okay, what was the purpose of that change? How you guys are going to provide change history to that particular customer? Somewhere tracking is most important, right? Whenever we are working with multiple team member, every team member, their role, whatever changes they are making, okay, changes they are implementing in their project, we need to track entire detail. And now tell me, if you have this kind of, okay, simple concept that you have a drive and file is there in the drive and only one copy of that file which you are using every time for modification, you guys are not able to maintain the history. Even it is very difficult to track. We can't track such a kind of file, right? Change information, you will not able to track. Correct? You will not get that information, no date, no time, nothing. So there is a problem. In every project, we should have some mechanism where whatever team members are working together, we should able to track each other changes. right? Any changes is occur, immediately we should get to know that, okay, this change is made by which tester or which developer. Are you getting my point? So whenever multiple team members are working together, this is not a good solution. So here came up, okay, one important topic that is called SCM, Software Configuration Management. Now, every organization, they don't maintain one single file, they don't maintain one drive where the team can work. They simply follow version control system. And what does mean by version control system? Please have a look. If I can show you the process. Initially, again, we have a team member, they are working together. And everybody is having their local copies, whatever they work, okay, on their local machine. Now, the main part is if everybody wanted to maintain their work and absolutely in same file, they don't wanted to change anything, then what happen? You will get here some repository. Now the term repository, what does mean by repository, guys? It is like a storage. In this repository, it's a storage, it's a container where every team member they can work and they can maintain their update. So what happen if there is a file, right? Already this is the file and we need to update it. Let's say developer A wanted to update it. So developer A will make the changes into file. So developer A will first take the copy onto the local machine. Developer A will make the changes into file and developer simple, add that file into that version control system. Whenever we talk about version control system, repository, if the file is updated, then for every file, for every change, it will maintain separate version. Means this is your latest version. Okay, latest file which is available on that particular repository. Tomorrow developer B can download the file. They can make the changes. Again, they can simple, again the developer 2 can or B can add the file. But for every new change, you will get a separate copy of the file. So what will happen, guys? With this help of particular structure, we are able to manage each other track, like when the changes exactly occur, what was the main purpose of that changes, who made the changes, all these things was all these, okay, questions, you are able to easily get the solution for this. You will get all the history, you will get entire tracking detail if you have a proper version control system with you. So SCM is all about configuration management, means related to your project, whatever documentation, code, script, anything you can maintain in a centralized repository. So that is called software configuration management. And how we can manage it? So we should manage it with the help of version control system. And that is what the topic we are going to discuss today. What is version control? Before version control, what was the issue? After version control, again, how many types are there? And which type we generally follow? All the points I will be covering. So just focus and understand the topic. Coming to the first, we need to start with again basics of DevOps, which you already know. So guys, first point, DevOps is not a tool. It's not a technology which is available in the market. I told you it's a culture or it is a process to develop, release, maintain software projects, application with a high quality in a very faster way, right? So here we are able to maintain our application. We are able to focus on that particular software application. We can achieve this, okay, in DevOps by using several automation tools. So again, it's not a one tool or one task. DevOps is all about group of tools, guys. So DevOps engineer need to have a knowledge on all the tools, but as a tester, we can contribute to the process. So we should understand tester responsibility. So for any software development or any release maintenance, there are two groups of engineer, okay, will work in the organization. Development and non-development, or we can also call it as operational or administrator group. So development group, you already aware. All the member, those are involved in the development process. You can say business analyst, designer, developer, tester, everybody. Those are comes under development group. So DevOps is a combination of development and operational team, right? So development plus operational tasks, both we are able to manage with the help of DevOps. The main objective of DevOps is what? Implement collaboration between development and the operational team. And that part we discussed in the last class also, correct? This will help you to collaborate between development and the operational team. Okay. So this is the life cycle of DevOps, and that is also we have gone through already. Very first planning, then developer develop the code, Then they build the code. Once the software is ready, we can test it. And once the testing is completed, manual automation, right? You can release the product into the production environment. And there comes deployment phase. Finally, we can go with operate, right? Where the operational team, they will take care about every update and every release, correct? Even throughout this whole process, I'm talking about throughout this whole process, monitoring is required. Monitor is something like starting from the first phase up to last. Okay, monitoring is compulsory required. Suppose if any failure observe here, anything which is going wrong, right? Again, we have to continue with the planning phase. So this is the complete DevOps life cycle. All these phases are there in the DevOps. DevOps is all about development plus operational team combination. So that's the reason this process is very, very important. Now coming to version control system. Okay, what is the main purpose of the version control system? See, it will help you to track the history of a change as the people and teams collaborate on the project together. Many people are working together, then we should make sure that, okay, every change we should able to track. So like as developer, make the changes into the project. Any earliest version of the project can be recovered at any time, right? So let's say you are maintaining now multiple files in the repository. Every file we have a latest version, correct? But suppose if this version file get crashed and I wanted to recover it, at least you will get the copy of the version in the previous file, right? So we are able to get that recovery also. Okay, we are able to track the entire history also. That's the reason version control is very important. See, normally developer can review this project, right? Developer can review this project, okay, and how they can find out the complete history. See, normally which changes are made. Let me again spotlight. Yeah, which changes are made, right? Who made the changes, when the changes are made, and why the changes are required, or why it were needed, right? So all this detail, whenever they will review the project, they will get to know. Normally this concept coming from the development guys. That's the reason you are able to see developer can review the project and they can find the history. So version control give each contributor to undefined, or I will say not undefined, unified and consistent view of the project, right? And even surfacing work that is already in the progress. Basically, you guys are able to track each other work. Whatever the changes made in the project, you will get a complete history because of the version control system. And that's the reason it is important. Okay, but let's see now basic terminology in version control. How we can start. So very first, guys, you need to understand what is working directory. See, working directory means it's a space where you are writing your logic. Now, if you talk about, let's say, developer, any editor developer are using, then that's their working directory, storage, where they are writing their code. Example, in our case, Eclipse is our working directory. Agree? So, generally, what we do in Eclipse, we write a logic, correct? Eclipse, we write our test cases. So, Eclipse is our working directory. So, generally, what happen? Working directory, it is an area where the developer are required to create, modify certain file. And here version control is not applicable because here we won't use a work like version 1, version 2. Generally, it's your space, the area where you are writing your logic. Correct? So I'm maintaining code inside the Eclipse, then I can say Eclipse is my working area. Okay? So that is your directory. Whenever it comes to the repository, it's a storage. I told you, right? Repository is what it is all about, the storage. So where we can store all the working directory code into repository? Yes, working directory programs we can store into repository. So this is the area where we have to store files, some metadata. What is metadata? Data about data. Data about that particular project, everything you can maintain. Here version control is applicable. Whenever it comes to the repository, version control applicable here, right? So here we can talk about versions like version 1, version 2. Okay, depends on that particular change. What is the commit and what is the checkout process? Everyone, commit means the process of sending file from working directory to the repository. So somewhere on your local machine, you are having working directory and you wanted to share a code onto the repository, then this process we can call commit. But what does mean by checkout? The reverse process, everyone. The process of sending file from the repository to back working directory, that is called what? Checkout process. So somewhere we can call it a check-in checkout, or you can say commit and checkout. That both terms are fine. But now we need to understand what are the benefit. If you have a version control, what are the benefit of that? Absolutely, guys. If you have a version control, we can maintain different versions, and even we can choose any version based on the client requirement. So for any project, you are maintaining multiple versions. Tomorrow your client is coming and client is asking, okay, please give me version 1 document. Please give me version 2 document. If you are maintaining all the file, you can immediately share that files to that particular client. That is the main part, correct? So we can maintain different versions and we can choose any version based on the client requirement. So with every version or every commit, we can maintain metadata like commit message. Here comes the main part. Whenever we do commit, message is compulsory. You need to add your message properly. So commit message is required so that we are able to maintain the complete history. So message, who did the changes and when he did the changes and what kind of changes he did, right? That normally we maintain through that message. So commit message and all we will see. But yes, for every commit, for every version, message should be there. Then developer can share their code to the peer developers in very easy way. Yes, if you are working in a team, you can share your code with each other, no? With the help of this particular process, version control. Even multiple developers, they can work together in a collaborative manner. Same process, guys. You can consider developer tester, both will be same now, right? So it is all about you. You can also work in a team. You can also work in a collaborative manner, so you can share your data with each other. Even parallel development is also possible. So now tomorrow you have a development team and QA team separately working, right? But now we can able to maintain our work easily. Parallel development, parallel testing, everything is possible because of the version control system. So we can provide access control, like who can read the code and who can modify the code. So through the version control system, this is also possible. You can set the access permission that, okay, is it that particular script is only read only mode or you can modify the same. But that's the main part, okay, that benefits of version control system, you are able to track the entire change history. That is the main topic, okay. Now coming to the types. How many types are there for version control? Let me tell you everyone. Very first, older approach, it was local version control. What is local version control? It means, suppose this is my machine. Whatever project related data it is, I'm just maintaining in a separate storage. But absolutely it is a part of my local machine only. And here I'm creating a storage and here I'm maintaining that file. So this is what only one person is able to access that file. That one person is able to manage their entire task with related to that file. This is called local version control. And why it is not suitable, why we generally don't follow it. Process is very simple, guys. In local version control system, many team members, they can't work together. Are you understanding? Because this is a machine, suppose, and a user is having this machine. Then only a user can interact with that machine. How come B and C user, they are able to interact? So local version control, it is there only for that local machine. And this is the older approach. So we don't follow this. Then what is the next approach? After local, they found what? Centralized version control system, or it is also called as subversion. But what does mean by centralized? Try to understand. Whenever it comes to the centralized version control, we will maintain one server. Let's say here we have a centralized server, and let's say you guys are having your local machine, correct? So what you do, whatever the code you will prepare on the local machine, again we have developer A, suppose, and here comes developer B, and both the developer are writing their logics and completing their task. Now developer A can commit the code to the repository, consider this is a centralized repository. Then developer A can simple check out the data also from the repository. Same process developer B also can do, right? Commit and check out. But what is the problem? When I committed the code, example as a developer A, suppose I committed the code, the local copy will be shifted to the server. Got it? So again same, whenever B user or B developer commit the code, local copy will be shifted to server. Now guys, we don't have that local copy on our local machine because we have already committed it to server. So everything will be having on a server, right? Now what is the problem? Whenever there is only one server and many people are working with that server, right? And tomorrow what happen? Every file you have shared onto that server, everything is there on that local, I mean central server only, not local, central server. But what is the problem everyone in this architecture? If any server get down, let's consider that your server get down, server get, let's say, server is down or network connection is not there, anything problem occur at the server side, and you don't maintain local copies on your local machine. In that case, you might lose your data. Remember, if any problem occur at the server side, you will not get recovery because now all the files, everything available only on a server. We don't have anything on our local machine, and that's the biggest challenge. Why nowadays we don't follow centralized version control system? Because of this reason. First of all, this is how we can communicate with the server. Okay. To perform this step, sometimes we need network connectivity also. But another point is what? If you don't maintain local file on your local machine and everything is available on the server, and tomorrow any problem occur with the server, you will lose your data and you will not have any local copy on your machine. And that's the reason we don't follow centralized version control also. So what is the solution for this problem? So we have decentralized, or it is also referred as distributed version control system. And the best part is not only distributed, you can say distributed remote version control system. So here we can able to communicate at the remote side also. What is distributed, Let me help you with the topic. So you have observed that whenever we are writing the logic in a centralized, so centralized concept is what? See, centralize, right? Centralize means there is a one server and multiple user, those are working on their local machine. What they are doing? They are sharing their data, everything on that server. This is the communication point, correct? But tomorrow, any server get crash, any problem occur on that server, you are not maintaining local copy, and that's the biggest issue. Everything on the server, and if server have any problem, you will not able to proceed, and your data will be definitely lost. But then we have distributed version control system. Now, first point, what does distributed version control system? Here, the system is very simple. First of all, they came up with this idea where what they did, like, okay, fine, every developer working on their local machine. So, very first, they are maintaining one local repository on their machine. Okay. And the point of distributed is what? One local repository to another local repository we can communicate. This was the particular concept. Whenever there is a repository to repository communication, the steps and commands are different. Generally, suppose this is A repository and this is B repository. From A to B, I'm sending some data. So basically, what is this operation? This is called push. Okay. From B to A, I'm again pulling that information. I'm just getting that information. So this is called pull. To understand, whenever you are on the local machine, and this is what your repo, right? The local machine to repo, action is commit, correct? And if you take local, I mean repository to local machine, then that step is called checkout. But whenever two repositories are communicating, always understand the process. Whenever two repositories are communicating, the process is different. Here we can have push and pull the command. Clear everyone? But what is the problem here? As you can see, again we are maintaining only one copy, right? Only one copy you are having, local copy. And where it is? It is on the local machine only. We can communicate with each other. I can have my B user data here in my machine also. But still, everybody's work we are not able to easily manage. And then they came up with this idea that fine, we will take distributed only, but this time we will maintain a documents on the remote server also. Not only on local, but we will add remote server also. And that is called distributed remote version control system. Are you getting my point? In centralized, only one server and all the local machines are there. This is the communication or connectivity. In distributed, first of all, they will maintain local repositories only and communication is possible. But still, A and B, they are not able to easily track their work. So they came up with idea, let's have a architecture for distributed remote version control system. And now, what is this distributed remote version control system? Just have a look. Here, I'm designing working area. Okay, this is the working area where the developers are writing their code. That's their local machine. Agree? So very first step, this is the local, I will say working area. Okay, first step. Now, how they're maintaining their code, everyone? I told you there we need a local repository. So initially, suppose I'm designing one local repository. Yes, it is a part of that, okay, local machine only. So I'm writing in this manner. So this is the complete working area and where we are maintaining one local repository. Let me come back. Where we are maintaining local repository. So at this moment, this is machine 1, this is machine 2, right? And for A machine, let's say for A laptop, and this is for B laptop or A, or you can take M1, M2, both will be fine. At this moment, this is the local area. This is A local area, local repository, and this is B local repository. So what is this second layer? I'm designing local repository. Okay. So what happened? Whenever developer writes the code, where they can hold it, they can hold the code inside the local repo. So guys, currently it is a repo, right? Repository. So at this moment, what will be the step? From working directory or from that working area, if you are sending your code into the repository, then this is the process we simple call it as commit. Correct? If you are maintaining the file and suppose tomorrow I wanted to read any file from the repository to in my working directory, then actually this process is called checkout. So I'm writing here. This is the process called checkout. So currently suppose B also committed the code into the local repository. Agree? So where the code it is available? It is in the local repository. But then we are talking about distributed remote version control system. That means here comes one remote repository. In, through the GitHub, technically you can maintain remote repository. So I'm just designing one remote repository. And now guys, see the solution for all the problems, whatever we noticed so far. Whenever you talk about remote repository, now from local repository, I can submit entire data onto the remote side, correct? But in remote side where you are going to store it, so by default, you will get one branch. Generally, branching concept is again very interesting part where you are able to maintain the data. So by default, you will get one branch and that branch is master branch. In the latest versions, you might able to see main also. Both will be fine. But both are the branch. Okay. And initially in this branch, whenever local repository data, whenever we are sending to this particular remote site, we are actually doing operation of push. And then data will be available on this site. Clear? Again, if I wanted to get the data back in my local, then this is the operation. We can call it as pull. Always remember. So at this moment, same happen in the B also. Local copy, I wanted to share onto remote. Then I'm doing what? Push. And if I wanted to get it back, then I'm doing pull. That's it. So repository to repository communication happen in this manner, and working directory to repository communication happen with the commit and the checkout process. But what is the benefit of this architecture? If you can see, your local copy of work, it is available now at a local repo also, and it is available in a central remote repository also. What is the benefit? Tomorrow any problem occur at a server side, right? Still the local copy is available on your file, on your laptop or on your machine. Tomorrow any problem occur with local, you will get the file from the remote side. This is the benefit where each other work we are able to track, manage, everything we can do. But this is the main part you need to understand what is this architecture. And now let me talk about your software. So we install two software, agree? Why we need two software first of all, everyone? How you guys are going to manage commit and the checkout process. This is your working directory task, local machine task, right? For local machine, you need a Git software. Remember. And for remote machine, all these tasks you can manage using GitHub. And there are many softwares available. GitLab is there, Bitbucket is there, right? But normally Git and GitHub is most popular one. Most of the real-time organization, they are following Git and GitHub. So I will be providing training for the same. Clear? So this is the architecture that you need to remember. And all these points I have added here. If you can see, this is the concept of centralized version control. If you can see, every developer, they have their working area. And centralized means they are maintaining everything in a same server. So version files are there. But what is the problem with this particular centralized version control? Tomorrow server have any kind of problem, you will lose your data because now the files will be on a server. Files are not with you. And that's the biggest issue. So just have a look. What are the problems with centralized? Central repository, it is the only place where everything stored and which cause a single point of failure. Because everything stored on a single machine and that is our server. If something goes wrong to the central repository, then recovery, it is very, very difficult. All the commit checkout operation should be performed by connecting to the central repository via network. I told you, right? Network is compulsory required. Then only you can communicate. And if network outage, then no version control, okay, to that particular, to the developer, we are able to maintain. All the commit checkout should perform by the connecting to the server, I mean to the central repository via the network, and hence the operation, okay, will become slow. So sometimes it cause performance issue also. And even organization of central repository is very complex. If number of developer, okay, of let's say if number of developers and file get increases, in that case, managing everything through one server, it is quite complicated process. So these are the problem, okay, previously we face in a centralized version control system. And that's the reason they came up with the idea distributed. But I told you, in distributed, yes, on every machine, you are maintaining your local repository. And we can communicate from one repository to another repository. But in this process, what is the problem and what is the challenge again? We are able to work independently, but we don't have any central connection, central communication point, right? Where every developer can work together. And that's the reason they came up with the idea distributed remote version control system. So here, just remember repository to repository, we have communication point push and the pull. These are the two commands generally we follow. Now see, what is distributed remote version control? You guys are maintaining same copy of file on both the repository. One in your local, another one at a remote site. So any problem occur at a local site or remote site, recovery is very quick. Easily we are able to recover the file. So every developer has its local copy of repository and it is not centralized, it's a distributed, right? So commit and checkout operation won't be performed on the remote side. There will be push and pull. Remember, we don't do commit and checkout, okay? Push and pull. Main job of remote repository is to just share our work with the peer developer. So whatever tasks you will do, everything you can maintain and everything everybody is able to access. High availability, speed, and there is no single point of failure because now the files are available on local machine also and a centralized repository also. Are you getting my point? So that's the reason this approach, distributed remote version control system, it's very, very popular. And we are going to learn this part. How to use Git software just to, okay, put, simple commit our code into local repository and how to use GitHub where we can just push our data from local repo to remote repo. All these points we are going to discuss. Correct? So for this, we have a multiple tools available, but the Git is the most popular one, guys. And that's the reason as a tester also, you should know what is Git and how to use it. So mainly, distributed version control system, where checkout commit will perform, this operation perform locally only. Here we use push and pull, you know that. Even to perform checkout commit operation, network is not required. Hence, hence, if there is any network outage, still the version control will be applicable, right? Again, if something goes wrong in any repository, there is a chance to recover. There is no question on a single point of failure. To perform push and pull operation, network is again required. Means normally for local transaction, network is not required, but for remote side, network is compulsory required. Remember that point. But these operations are not most, we can say, common operation, right? And we are performing very rarely. But still, it is important to know how we can perform it. So just remember the point. Okay, this is how the architecture works. First step, when we do commit and checkout and when we do push and pull. Commit checkout will be performed on the local repository. I will say on a local machine. So you are writing your code in the working directory. This is your working directory and this is the repo. And I wanted to share working directory code to the repo, then we do commit. And repo to working directory, then we do checkout. Very simple. Whenever you have repository, let's say this is my remote repository. And now from local repo to remote repo, I wanted to have some data. Then there is a step push, correct? And from remote repo to local, again you wanted to have some data. Then actually we are doing push, pull. Here, network is required. Normally for local communication, network is not required. Clear? But remember, if you are doing something related to server, then network is required, like a centralized part. Whenever you have a centralized thing, in centralized architecture, network is required. So these are the operations only I have mentioned: working space to repository commit, repository to working space checkout, and one repository to other push, and again pull the detail. We have simple pull command. Clear, everyone? Now, what is Git? So Git is a distributed version control system. So Git is no acronym, or hence there is no expansion. So normally many people says that global information tracker. Git is what? Global information tracker. Actually, it is developed by Linus, and who also developed the Linux kernel. Okay. Normally, most of the companies, Microsoft, Facebook, Yahoo, LinkedIn, all they are using, simple Git for their version control system, for their software configuration management. And that's the reason it is very popular. Now, coming to the main part, what are the features? Okay, features we will see, already we discussed also, right? Here, when you have a proper version control with you, everybody they can work in a collaborative manner. Agree? Copies of the file we are maintaining on a local machine in a remote side also, so recovery is possible. Agree? There is no single point of failure, right? So these are the points only you need to remember. And local operation we do offline, means without network. But whenever there is a centralized server or maybe remote server available, you need a network over there. So backup, recovery, everything is possible if you have a proper distributed version control system. Clear, everyone? Now, the main part. So I wanted to show you some important architecture of a Git, how we proceed. So now please have a look. What exactly this Git architecture it is and how we can simple proceed with the same. So I'm taking different color, just notice. So guys, very first, here is I'm having local, let's say working directory. I'm writing this is my working directory where we are maintaining the code. It's like a Eclipse. Eclipse where I'm maintaining the code, writing the code, right? And I'm explaining to you overall local repository or local task. Everything we are doing on a local machine. Let me write local machine. Better. The first step is what? This is the working directory where you have prepared the code. And I wanted to pass this code where? In my local repository first, right? So consider I'm maintaining here one local repository. When you talk about local repository, I'm writing in shortcut local repo, and there you will get one branch, that is also named as master branch. So by default, I want this code to be passed here into local repo. But you know what? You can't directly share like this. There is a one more layer available in between that is called stage. Stage area. What does mean by stage area? Here, we usually maintain snapshots of that particular data, whatever data you wanted to pass into local. So it is like, okay, where you can confirm, really you wanted to commit this code onto the local repo, right? So here it's like a preview process. We can have a preview. Whatever we are trying to submit, just take a preview of that. So this code will be shared to whom? Absolutely stage area first. Then in stage area, which is also referred as index area, you will get one copy of that particular code. Same code copy you will get here. And then if it is confirmed, yes, this is the code which I wanted to store into my local, right? At that moment, what will happen? Here, stage area code, we can share into our local repository. Then code will be there into your local. So these three steps we have to do, second step and the third step. These three steps we have to follow on our local machine. And here we need Git. I hope the points are clear, right? From the Eclipse, we are understanding how we can pass the code into the stage area first. It's like a preview. And when you will confirm it, you can just pass your code to the local repository. But currently, where is all my data? Everything is there on my local repository. Now, guys, just have a look. This is a local, and now I'm designing the remote site. This is the remote site where I'm having remote repository, correct? So through the GitHub, okay, through the GitHub, first of all, you are able to maintain here one repository. So currently this is my remote repository. You can understand. And again, in every repository, you will get a branch, right? And that is a by default master branch. So this is my remote site. What I wanted to do, once the files are there into local, these files I can directly attach into remote site. So here the final copy of a code that master will get. Suppose after modification, whatever the final copy of that particular project you will be getting in the master, you can directly get that detail in your local repo also. Every communication is possible. But question is how? So once you have a Git software with you, once you have a GitHub account, repository you can create, and through the Git first, you need to follow command. Now commands plays very important role in Git. Every Git command starts with the Git prefix. Okay? Means very first. Whenever I start working directory, there is my code which I wanted to send to the local, right? How you guys are going to create local repository? So we have a command git init. First of all, initialize empty repository. The command is very simple. Git init, it will initialize empty repository. After that, to add your code from working directory to the stage area, the command we have to write git add, give space and then dot operator. Dot or asterisk both will be fine. Here, dot means all the file. There might be possibility I'm having 10 file total and all 10 file I wanted to store into local. So using git add and dot, you can share all the copy of file into stage area. So this is the second step. Once the file into stage, here you can make a preview, check that everything is fine. Really wanted to, send this command, send this document to the local, that you can take a confirmation. And once it is done, then we have to commit. How we are passing stage to local repo? We have to do commit. How we are writing command? Git commit -m and the commit message, which is important. Purpose of that commit, we are adding. Then finally, we'll get a code here. And then from local repo to remote repo, if you wanted to share, this is our remote repo, right? So if you wanted to share your code, then here we do push command. And just to get the code, anything from remote to local, we do clone and then we do pull. Clear? So this is the main architecture you need to understand, how the Git is working on a local machine and how the GitHub is working from the remote side. Any doubt on this? Okay, practically there are many commands that we need to follow. But is it clear first step?
Yes, ma'am.
I'm assuming. Yes. Okay. So please have a look. Now there are many things I will be talking about branching, merging and all. But yes, this is the architecture just now I have explained to you. Very first, we have to start with working directory, add the code into stage area where we can take preview and then we can pass it to the local and from local we can pass it to remote. But these are the special command. Without this, it is not possible. Correct? So how we can begin with the command everyone? Just have a look. Now what I'm going to do is how to send the code on remote side. Everybody aware, right? So at this moment, let me show you still again because of this practical how we can start. So even in this PPT, all the command, their meaning, everything I have added. Just once you get a chance to go for it, right? But again, some file structure and the initial status important to know. Whenever your files under your working directory and whenever you check the status of this file, very first you will get all the file are untracked file. Untracked means what? It is just newly created and we don't have these files in the stage, right? Currently files in the working. So it is by default you will get untracked. When you stage it, the file status will change to track. File status will change to track. Means currently it is in the stage area. And then that file you need to pass to the local repo, right? So we are doing commit process and that is what repository, the files will be committed into repo. And then if any file you modify, right, in that case you will get modify. This is the status for that particular file. So I'll show you this part practically, how exactly it is and how we can proceed. And then git init, this is the command which will help you to create an empty repository. Status, add, every command I will be showing to you. And very first we need to start with global configuration. So if you remember, we discussed, okay, that how to create a remote site, GitHub. Now I will show you how to create a repository on the GitHub. And then I will show you all these steps, how you can proceed. So the first point is, okay, let me open Eclipse. And at this moment, I'm just going to open GitHub. First of all, I will show you on my machine. Then I will take your system and I will show you on your system also what the steps you need to follow. Okay. So let this open GitHub first. And let me log in. First, you need repository. Okay. So let me log in with my email and password. Okay. Whenever you come to the GitHub, how to create a repository, either on the first page, you can see, you will be able to observe this plus icon. Create new repository. Otherwise, this is the right hand side where you can see your profile picture, right? Whenever you add it, you will get it here. Otherwise, blank, some kind of photo you will get, right? Basic photo. Click on it. And there you can see the second option, your repository. Correct? When you open it, in your case, it might be blank, right? But then how to create a new? You have to just click on this new button. When you click on new button, everyone, it will launch this page. It is asking create a new repository. Agree? How we can start with the new repository? You have to give a name. Give a names which is something meaningful, right? Suppose I'm just writing testing git. Okay, let me write here. This time, let me take a text. I mean, let me just close this particular, my highlighter and let me write testing, okay, git training. And I'm just writing, it's a weekday batch, okay, that's it. So currently I'm just showing you a basic repository. Later on, you can delete also, doesn't matter. So you can see I'm getting the message your new repository will be created testing git training weekday batch. Okay, so automatically you are getting in this manner. Fine. So I'm just writing, okay, fine. This is sample, okay, repo. This is sample repo. Fine. And then guys, I will come down and see there are many options. You can make it private repo also, public repo also. It is up to you. Then add readme file and all. It is all about if you wanted to write a long description about the project, then you can add a file and there you can write it. Okay, every step and information you can maintain. Then at this moment, git ignore and again choosing license step, we don't need to do, just create a repository. So once your repository will be ready, you will get this page. Fine. And there you can see two formats you can able to see. HTTPS by default, you will see HTTPS only. Hypertext transfer protocol, right? And here it is secure shell protocol. Generally, both the protocols are available through which you can get the URL and you can simple, this is a remote side URL we can say where we can send our data. So at this moment, anyone you can choose. For SSH, I will show you some different steps you have to do. In my machine, I'm just having both the setup, HTTP and SSH both. So I'm using SSH. In your case, start with the HTTP first. Fine, and that I will show you. Okay, and see, these are the commands they have initially mentioned. Okay, you have to start with git init, then do first commit, then add to the branch. Okay, we actually switch to the branch to the main because currently by default in the new GitHub, you will be able to see main is the branch. And here you can take master also, doesn't matter. Okay, main master both will be same. And these are the steps they have already given on that repository side. Fine, currently my repo is an empty repo. Okay, I will first come back to Eclipse. Now just have a look. I'm just switching the space to your batch. Just a minute. Now already whatever project we did so far, we have uploaded everything on the GitHub, correct? So I'm just creating a quick project and I'm just trying to show you the same. So any project you can create because it's a very basic, okay, training I'm explaining to you. So just have a look. I'm just preparing some Java project. I'm just writing Git training. Fine. Done. And on Git training, just have a look. Now, this is the project. Let me finish. Project is ready. Okay. And now suppose I'm creating some package. Just have a look. I'm creating some package, test package. Com dot better test. Fine. There I'm going to create a normal class. Okay. Normal Java class. Let me write, okay, first code. I'm just writing. And here I'm taking main function. Okay. My class is ready. And here I'm writing that particular code. So let me just print statement. Hello, everyone. Okay. Welcome to learn. Welcome to learn Git. Fine. So I have just maintained something here, some message here, and let me save it. Now, guys, just understand the topic. This is your project, and you wanted to share this project from your local working directory to where? In your remote site. What is the step for it? So now you need to understand the architecture, whatever we discuss. Initially, code is available in my working directory. Whenever you wanted to share it to the remote, we need first local repository to be created. And how to create this local repo on your local machine? It is possible with the command git init. Correct? So we have to start with this process now. Then we are adding it to stage. From the stage, we are adding to local first. And then from the local, we are going to push it on where? On your central or we can say remote side repository. Clear? But let's see how we can proceed. Now, I will come back to Eclipse. First step, where is the project? Come to that location. So I will just open. Okay, this location, my project is available under learning folder. Let me just come to the system. And this is my project, right? Just now I have created. Open it. First of all, come inside the project. And then you can right click and there you can open git bash. So yesterday, I mean in the last class, we discussed how to install git bash on your local machine. So this is like, okay, git bash where you can see. This is how the basic editor you can see, right? Now in git bash, very first step, what I will suggest to you, do first configuration. First time whenever you are doing, I will suggest you to for the configuration first and don't worry, I will be covering steps on your machine also. Because in my machine, already the configuration part, everything is done. So it will not create any issue for me, right? So I will be showing you, just be ready with your machine. Now coming to this part, how I can begin? I need to first have my local repo right in my local machine. So just write a command git init. See what is the message coming? Initialize empty git repository and where it is in the same folder, and there you can see .git. One folder you will get that is called .git. Now .git folder, it is what? The main repo where you can store everything. That's your local repo. Now guys, let me show you this step. If I come back to the folder, can you have a look? You are able to see this .git here. Okay, there might be possibility if you have a setup that maybe your folders are hidden, right? In that case, you will not able to see. After running the command also, if you are not able to see what to do, just come to view and come to show and just open hidden items. You will able to see that. So my first step is completed. My local repo is ready. Now guys, initially, if you remember, I told you, currently, where is my file? All the files available in my local repo. I mean, not in the local repo, it is in my system for now. Correct? I just created empty repo. And that is what you are able to see here. Empty Git repository we created. Files are still in my working directory. Agree? How to proceed? So, check the status of current file using command git status. Please make a note. What it says, we are on the master branch. The branch is a master, that is fine. But no commit yet. Means files are not there in the working or in the local repository. Do you remember commit we do for the local repository? So no commit yet. And what is the current status for my file? All the files are untracked only. And here you can see red color. The color combination also important. With the help of git bash, you will understand better. These commands you can try on command prompt also. But always a good practice if you are using git bash. Fine. So at this moment, all the files are untracked. But how we can track it? Yes, whenever file get attached to the stage area, files are here, then only it will track. Getting my point? So initially all the files are untracked and even Git is guiding you. Nothing added to commit, but untracked file present. So use git add command to track it. So initial status, whenever files are in working directory, you will get untracked file. Great. Then I wanted to track it. How we can do that? Now there is a possibility. You might tracking one file. You just wanted to add, okay, two file, or maybe you wanted to add all the file. Best option is you can directly follow the command git add. If it is one file, just give that file name and you will able to track it. But at this moment, whatever there in my project, I wanted to add everything to the stage area. So I will be writing give space and then just write dot operator, press enter and see your staging task is completed. But how you will confirm it? Is it really files are tracked or not? There come a one more time message. I mean one more time a same command git status. Check the status and let's to confirm. Whenever files are tracked, see the color. Everything you will get in the green color. It is again saying that, okay, fine, we are on the master branch, but no commit yet means your local repo is still empty and changes to be committed. So these are the file structures available where? Into stage area. And now these are the stage area files ready to commit into local repo. Agree? But how to do that? Now one more thing. There might be possibility. I told you what is a stage area. It's like an index area and where you will get everything in the form of snapshot. And the possibility is what? Like here we can do the preview task. But if you really wanted to, again, maybe some files are wrong and I wanted to get it back in my working directory. How it is possible? You know, for that they have given this command. You can go with git rm cache and then you can put the file name and that file will be again go back to the working directory. So I'll show you with the different file structure. Currently, we are directly adding our entire code, okay, on a GitHub site. So just have a look. So this is the command guidance, everything you are getting from that git bash also. So currently where we are? Currently I'm in the stage area. Okay. Then I told you we don't need any network connectivity, nothing whenever we are doing local tasks. So from the stage, now I wanted to send my code onto the local repository. So we are here, and from here we are going to send to local. How we can send to local? We have to follow the commit, git commit command. So guys, we have to write git do commit, and every commit you should pass commit message. Without commit message, you will be not able to do this. Okay. No, Ravi. Currently, we are in the local machine only, so we don't need to switch to the branch. Branching, okay, I haven't started. I will cover what is branch, right? So currently, we are on local itself. See, it is the local master branch only, right? So at this moment, when I do commit, it will do what? It will just come to the local repo. So just you need to add commit message. How we can add a commit message? Put -m, and there you can do the commit message. So guys, what is the commit message? Suppose I'm writing first project commit. Fine, I'm just writing in this manner, first project commit, and that's it. Enter. Fine, I'm able to commit. So where my files are available, now all the files, everything you will get inside your local repo, right? See, if you wanted to check the status, how, like what the commit we did, what is the commit ID for that? So basically this is the master root commit, and this is something ID you are able to see here. But if you wanted to check the log also, you can do that. That is using command git log. Now please have a look. What is this git log command? Git log, where you can see the author name. I'm having that particular my detail. This is the complete commit ID you can see. And plus you can observe here something called head, and head is pointing to the master. So guys, what is head? Head is a pointer. Whatever commit you will do, let's say now in the future, we can do many commit, right? Like I did in the every session, I'm doing commit, right? For every particular code, I'm pushing onto remote side. So suppose starting from this line, let's say I did three commit, commit one, commit two, commit three. When I did first commit, my head is pointing here, correct? First commit. If I do second commit, now head is coming to here, right? Second commit. If I do third time commit, again the head will remove from here and head will come to here. So currently I'm on master branch by default, correct? So I don't need to switch the branch, but head is pointing what? That we are on the master, and this is the commit, whatever you did. Recent commit, I can say. Most recent commit information you will get because of that head pointer. Clear? So here you are able to see the log. Okay, at what time, which user, who was the author for that document, and at what particular date or time that particular user has committed some data. Everything you are able to log easily because now we are using version control system. Got it? But one more point. Where we are? Currently in which area? If you can talk, currently we are in the local machine. Still in the local machine, right? We haven't connected to the remote. So currently I'm still in my local machine and my repo where the files are available. This is my local repo. But I told you, suppose I wanted to maintain everything at the remote side. How we can do that? On remote, we already created one repo, agree, and there is already master branch available. So actually we are trying to do what? From this master, local master to remote master, we are trying to push our code. I told you repository to repository communication with the push. So how we can push the data from local to remote? First of all, we need to connect with the remote origin. Agree? Where is your remote? What is that remote address? We should have it. So before push, you need to maintain some relation between local and remote. Because see, if I try to write directly command, that will not work. Let me show you error. If I just write git push -u origin, just have a look. Origin to master, because I know at remote side also there is a by default master branch is available. If you do this, see I'm getting origin does not appear to be a git repository, could not read from remote repository. Please make sure that you have correct access, right? And the repository exists. So why I'm getting this problem? Because I'm still in my local machine. I haven't did any connection with the remote side. And there come now this command everyone. See, commit we did. We are on the same branch, master branch. Okay, if you want, you can change the main branch also, but I'm taking master. Very simple logic. But you can see there is a one more command, git remote add origin, and here you need to provide your current repository address. Are you getting my point? Because how the local machine will know na, where to push this data? We should have a remote address, and for that reason, this address is important for us. At this moment, I will copy the address manually, come back, and I'm just writing the message. I mean, simple command, git remote add origin, and there what is origin that you can paste here. But remember, in git bash, direct shortcuts will not applicable. If you write control C, control V, that will not work. So better right click, and there you can do paste. Fine, this is the remote address now attached, and then I can do enter. Clear? Okay, there is a one more command, git, let me just check, remote hyphen V. This will give you the origin detail. Let me check. Yes, can you see that? Whenever you write git remote V, now I'm having some origin. So I'm having the address of repository. I have connected with that remote site. Now I can push the data. How you can do that, everyone? You just need to write git push hyphen u origin to which particular branch. So you have to write master, right? Please have a notice. At this moment, easily push is completed, but please make a note. What is coming here? It says on that Git repo, you will, I mean, the remote repository, new branch is added, that is a master, and master to master means what? I told you, local master to remote master, we are trying to share a data. And that's the reason, come back to your remote site where you can see the detail. Just open, come to the code, guys, and here you can see your project is uploaded. Clear? This is what we are just passing our details on a GitHub. And you can see I'm getting one branch, that is a master. There are many things how we can create a branches. Then what is the main purpose of branches? What is the merge? How we can do merge to the master branch? What is merge conflict? How you can resolve it, right? All these points we are going to discuss. But this is the first step you should know. If you have anything on your local machine, how you are able to share to the remote site. And I hope it is clear. But I told you, and on my machine, every setup is done. You don't need to do a basic changes also. But now let me take your system, and I'm trying to help you all these steps on your machine. So that first time, because first time whenever you are working with GitHub, you need to have, okay, authentication. You need to complete authentication process. Without authentication, it is not possible. So if anybody is there, you can share a screen, then let me help you. At least first time, what the steps you guys are going to follow. And then tomorrow we will continue with the branching, merging concept, and then we will proceed with our next two, right? Okay. Who is going to share a screen now? Okay, last time. Okay, Sheetal. Sheetal wanted to share, right? Just a minute. Let me stop sharing. Let me allow you. Yes, now you can share. Okay. Now everyone just observe carefully what the step first time you will be doing, right? Okay. So let's say now Sheetal is having account, right, Sheetal? So do one thing. First of all, create your remote repository. How to create? Come to your profile or just click on plus icon. Both will be fine. There is your repository option.
Your repository, right?
Correct, correct. Your repositories. And there you can just click on new. Okay. Here you can add your repository name. Currently, suppose you're learning Java project, whatever it is, right? You can create as per your project. Right. If you want, you can add a description also. That this is a repository about Java. That is fine. Okay. Keep it public only. Just come down and click on the create repository option. Okay, so very simple step and you will ready with your repository, right? Yes. Now come back to Eclipse first. This you can minimize. You open Eclipse?
Yes, yes.
Okay, but I'm not able to see. Maybe
Okay,
you have to
fine,
share
fine.
full screen. Just stop sharing and share the entire screen. Then I can see the multiple file.
Okay, fine.
Yes.
Is it visible?
No. Wait. Now share one more time and just share as an entire screen.
Or entire screen, where entire screen?
First option.
Yes,
First option you will get,
yes,
right?
yes. Got it. Now is it visible?
Yes. So coming to your project, just do right click on a project. Yeah, and you can come to the properties and just open that location. Yes, come to that system location. Can you see there is an arrow? You can read location and there is a complete location given, right? Right hand side. C user del and there is behind that you can see arrow. Click on arrow. Yes. So this will shows that location of a project in your system. Okay. So currently this is your system and where you have this particular folder available. Got it?
Right.
So you just open that folder first. See, you need to come to the location and then from here open git bash. So right click. No, right click anywhere, empty space and just show more options. And if git is available, you will get that option git bash. Open git bash here. Correct. Okay. Now make a full screen and little bit you can increase the font if you want. That's it. So now I'm sharing first. First we have to do the global configuration. Okay. So for that I'm sharing some command in the chat box. You have to copy that command. Even though you don't do at the time of commit, it will ask you to do. Right. So chalo, better we start with the init directly. So can you just write one simple command? Git space init. Git init. No. Shidal, git command started with git only. Git space init. Enter. So see, now in the same location, you can see there is a empty repository created. If you wanted to confirm it, go back to folder and check. Dot empty folder you will able to see in that folder location. Now you can see if it is not there, I told you what to do. Go to view. No. Come back to folder. There is a view option. No. See on the top. You can directly choose. No. Don't do that step. I'm not asking you to right click. Can you see in the folder itself, there is on the top view option is available. Click anywhere. Sheetal, click anywhere else. Just on this screen only. You can see there is a view. Come to show. And there is a hidden item. Click on it. Can you have a look? Now there is a folder available. Come back to Git Bash again. So we created first step, empty repository is ready. Now what to do? Second step is we need to check status. So just write a command git status. Initially, all the files in your working directory only. So you will able to see untracked file. And that is what you can see here. All the files are untracked. Now you can do one thing. Just track it. So how we can track it means we have to add a file into stage. Write a command git git space add and just put one more space and then put dot operator. Correct. Enter. Right. Just confirm the status one more time. Let's see whether all the files are tracked or not. If it is tracked, you will able to see in a green color. So git status, that is a command. Enter. See, all the files are tracked. Now you can commit, right? Let's do commit. Let's write a command, git space commit space -m. Commit message compulsory you have to write, you can't keep it empty. -m for yes. Then give space and double quote and you have to write a message. You can just add first commit. Fine. Complete double quote and enter. Yeah, if you wanted to change, you can change, no problem. Okay. And
Means
here come the main part. Yes, Ravi.
dot means all file, right? And
Yes,
if
dot means all file. And suppose any specific file you wanted to add, you have to put the name. So example, here I can see many files are available. So if I wanted to add only one file, right, then I will be writing first code.java. Correct? Only that file will be attached into commit, means your local repo. But I told you, right? Like here, very first, even though you try first time, you will be not able to directly push your data or add it directly into local because it is asking you first, okay, author identity is unknown. Here, your Git is not sure that okay, you are a correct author or not. So for that, you can see they have given you certain guidance. Please tell me who are you and how you can do that. See, they have given the command. You need to write first your official email ID, whatever you set on GitHub. So I will suggest complete these steps and whenever you see this message, copy that first command first. Git config global. Yes, as it is copy. And I told you in Git bash, no shortcuts allowed. So select that command, right click and do copy. Then come to that main part again, right click and do paste. And just do one thing, whatever email ID you use for GitHub, no, just write here. Instead of that, you just write your original email ID. No. Shital, why you are deleting the command? Just need to update email. Rest of the part remains same. User.email remains same. And after that, in double quote, they have given sample email. No, there you need to write your email.
Okay,
That's it. Okay, complete the same syntax, do enter. So you will not get any message for this confirmation or what, but just you will get a next line. Next line, we have to run next command. Again, same process. Do copy, right click and copy. And paste it again, right click and paste. And only change your name. Now, which name everyone? The name which you have written in a GitHub. So check your name, confirm it. What's your profile name? So same name as it is, you have to enter here. Only in that name area. Do enter now. So this means we did configuration, right? Now Git will allow us to commit because now you have sent your identity to Git. So again, you can use up arrow of your keyboard and see you will get the same command, git commit -m first commit. Yeah, either you can use up arrow, you will able to see it directly.
Git commit.
That's it. This is the command we wanted to do, right?
Okay.
So now you can enter. Can you see? Committed. Check the log. Just write git log space log. Enter. So here you can see first commit did by the Sheetal, right? And this is how the head is pointing to master. Okay. Now we have to push, right? But I told you how you can push it. You just need to have first remote origin. So now do one thing, come back to GitHub first. Now you can see there is a by default, you will able to see HTTPS address, right? Copy that address from the top. There is a copy option available. You can either copy manually. Do copy, come back. And here write a command, git. No, not now. Write a command first, git space remote space remote te space add space Yes, Ravi, that part we will be covering tomorrow. How we can add multiple files, right? Okay. Git remote add and origin. And then you can just give a space and then do right click and paste that entire copied path. But again, same thing, first time whenever you are doing, it will ask you authentication, okay? When you try to push. So do it, enter. Okay, now try a command, git space push space -u flag. You need to just write -u space origin. And you need to write space the branch which is master.
Which
Right?
branch?
Master. See how you will get to know that where on which branch. You can see in the bracket the branch is coming, right? Name master. But do enter. This will not push. It will ask you for authenticate first. And wait for their instruction. Yes, can you see one more option is coming? I mean, one more some window is open in the taskbar. Can you open that last window? Yes, this is for authentication. Everybody listen carefully. First time whenever you are trying to push your entire code from local machine to the remote, this step is important, okay? So do authenticate. How to authenticate, guys? So first of all, use the same first option, sign in with your browser. Then it will directly redirect to this page. Now here, just click on that green color, authorize Git ecosystem, green color button. Yes, enter, I mean click, and it will ask you to log in. Means write your password and confirm. Write your password and confirm. Okay. Once the step is completed, kindly wait. Let this complete properly. Or you can come back to Git bash and check. Is it code pushed properly once you authenticated? And yes, can you see that? You got the message? Yes. Please complete authentication in your browser. Okay. And here you are getting the message. Then go back to browser again. Here it is nothing left, right? Come back to GitHub then. Come back to GitHub. In the same browser, the second tab. Sheetal Jadhav, right? That middle tab, you need to open Sheetal. Yes. Open it full screen and just click on code. First option code and check whether code is available or not. Yes, can you see that? First commit is completed. Now whatever you have created, okay, everything you can see here. Come to SRC. Yes. So this is your assignment, core Java basics, your package, and there whatever code you did so far, everything you can see. So clear everyone? As a tester, again, I told you these tools are coming from the development side, right? So developer need to use more and more, okay, in multiple way. But as a tester, we should know at least basics. And that is what we are discussing here. The very first step, today we have understood only the basics of GitHub, what is version control, what is centralized version control, why they came up with distributed, again in distributed, what is distributed remote version control, right? Then I discuss about the architecture. So, and this is the last step, how you can simple send your project from your local repository directly to the GitHub. So everybody try this. Tomorrow, I will talk about, let's say if you have a single file and suppose we are creating multiple branch. Why we need first multiple branches? If we do it, then what is the branch? How we can merge the code to the master? Okay, that entire process we will discuss. And the third process I will show you, if you have something in a GitHub, how to clone and how to, add that project in the Eclipse. That step we are going to complete, right? So this is how the step you have completed. Try it out and let me know if you face any challenge. But properly follow each and every step. Okay, one more point. This PPT, right? Where I have discussed all this commands and all, right? Complete architecture and all. So I'm sharing this PPT in your drive. Just download it from there and you can use it. Okay, everyone? Yeah. So I hope process is clear and we will continue remaining topics in the next class. Chalo. Thank you, everyone. Let me stop the session. Bye-bye. Have a nice day.
Bye.
Thank you.